Cable wiring and insulation. I think the name of the class has changed since this PowerPoint was actually made up. I think that's the title of the books we were using that cost so much money. How can wiring cable be installed? What is the advantage and disadvantage of various insulation techniques? How are wires and cables spliced and terminated? We've already looked at that. We're looking at soldering. In here, we're going to start looking at using crimp splices. What's the difference between medium voltage, low voltage, splicing, and termination? So we'll get a look at different ways we can handle these high voltage cables and these medium voltage cables. But we'll have to do those with videos because the splicing kits for those cost a lot of money. Some of the terms we're looking at is bending radius, conduit, fish tape, penciling, splice, electrical continuity. We use the term continuity a lot. Usually when we use the term continuity, it means we have 0 ohms between 2 points in a circuit, right? Understand that, or close to it. Most of the time our meter will show something, even if it measures the meter leads. And of course, hopefully we know what termination is by now. And that's not going to be recorded because it's outside the recorded. Conduit. So what is conduit? It's a tube or a trough that we route cables or conductors through to protect them. Everybody understand that? So we have different types, and we'll try to go over to the motor control, the commercial wiring lab, either at the end of this class or Wednesday, and look at some of the conduit over there and some of the fish tape and some of the stuff that they do in that class. But conduit, we have, of course, troughs. So we come over here and we see these outlets every once in a while. Well, how did those conductors get to these outlets? Through a conduit, right? I understand that. So it's a trough conduit. So we have rigid conduit. We have a rigid steel conduit, zinc coated, which should be used outside. We have rigid conduit, enamel coated. We have electrical metallic tubing that just about everybody calls EMT, or some people call it thin wall too. So when they talk about thin wall, they're talking about this electrical metallic tubing. Flexible steel conduit. I don't know if we got any over here or not, but we got plenty of different places we can look at it over in the building A. We have underfloor steel restways, which is what we probably got under here, right? We have steel wireways, we have steel busways, we have liquid tight flex conduit, which if you got an outside HVA system, odds are you see this liquid tight flex conduit going down there. Auxiliary steel gutters. And what's nice about this chart is it shows you where you have the ability to run this stuff. So EMT, where can we run that from? So P means it's what? Permitted. E means in some exceptions. X means it's not permitted, and the conditions do not apply. So EMT, which we teach a lot over in our commercial wiring lab, you take commercial wiring, you'll learn how to bend this stuff and route it and all kind of neat stuff. This is permitted where? It's permitted in inside buildings, outside buildings. It's permitted underground. In central field, we have to get an exception or see what's going on there. Embedded in concrete, we can do that. Wet locations is permitted. Dry locations is permitted. So we can tell a lot about just this on where an electrician would use this conduit. And unfortunately, we don't bend here, but we need to look at how we get that wire into those conduits and into those troughs. So that's why I left off. On your thing, so there's another term we need to look at too. We'll go ahead and put that in there. And we're running out of space. I might have to split this over 2 slides. We got a term called pulling. And the pulling is where we thread the conductors or the cables through the conduit or the trough. So that's another term that we need to get out of the way. I need to add it to the list. So it looks like we're going to be, so conduit below ground, most commonly used, we usually use fiber. Type 1, we can do what? Can encapsulate that in concrete. Type 2, we can bury that stuff directly into the ground. PVC type would be able to bury in the ground and run that through conduit. Above ground, we're going to look at EMT, also called electromagnetic tubing, also called EMT, also called thin wall. Hear those terms? They're all talking about the same thing. IMT, which is a little thicker, we can run that above ground. Rigid conduit. What's nice about rigid conduit is we can mount things on it without really supporting it. EMT has to be supported a lot, so we have to clamp it down and all kind of stuff every so often. PVC is very popular. This is not the white stuff. This is the gray stuff. It's got schedules on it just like the PVC that you buy for your house. So if you went down the Lowe's and got over the electrical department, you'd see the PVC that we can use as conduit. Liquid type flexible non-magnetic conduit, and then flexible magnetic conduit. So these are different types of conduit. So if we were going to, these ceilings are too high, but if we look on these fluorescent bulbs right here, now they would have conduit running through the ceiling, and then they have a box up there. We call them pull boxes or device boxes. But running down to the ceiling is flexible metal conduit. And of course, the metal is the jacket, right? What's the jacket in there for? Yeah, it protects against the environment. And of course, these things are constantly vibrating. The ceiling moves all the time, so we don't want to run any type of rigid conduit down there. We can see conduit over here where they ran the power for our robots. You'll see it running across the top of the wall over there. We can see conduit back here on the wall, that plastic conduit back there on the wall beside the board. See that. We can't see this conduit or the trough running under here, but they're definitely under. We see plugs mounted on the wall. Well, how did those cables get down through those concrete blocks? They're not going to run cable down through concrete blocks, right? So what did they run down through there? They ran conduit down through there, right? Below ground systems, we have these running all over the place. Some people are lucky to have their power run underground. A lot of times you go into a city, you won't see any telephone poles within the city itself or power poles because all of it runs in an underground system, right? You understand that? Above ground, we usually use rigid conduit, or we use what we call thin wall. So rigid conduit can be threaded. It's usually threaded, so the couplers that we couple this thing together or the joints that we couple it together are going to screw on. Normally on thin wall, we don't thread that because why? Because the walls are too thin, right, to put threads into. So we'll use different type of compression couplers and joints and stuff like that that we use on thin walls. We use thin wall a lot. Rigid is real hard to bend into shapes, of course, because it looks a lot like some of the old plumbing pipe that we had. Thin wall is a lot easier to bend into shapes to make it go around things. EMT fittings, we'll look at some of these. So this is what we do to join the thin wall together. We have straps that we use to actually secure it. We have compression type connectors where we don't have to screw down on the side. We twist these together, and they actually compress as you screw them together. We have set screw connectors, which basically you slide the conduit into it, and then you have a set screw that you do what? That you screw down in there. We have set screw couplers that would couple the conduit together. And then, of course, we got the lock nuts that we do to actually lock the actual couplers together. I don't know if they show any threaded couplers or not. So we have all this over in the we don't have any drive-in straps, but which are these guys up here. I don't think we got any over there. We do have what we call liquid tight. Now, the problem with EMT, metal EMT can literally be used as a ground conductor because it's metal, right? You understand that? So it's usually connected to ground. We might run a ground, but legally, EMT can be used as the ground conductor. But if we go through a liquid tight connector, then that liquid tight has got to have a rubber seal in there, right? You understand? So if we use a liquid tight connector, normally we have to have a grounded conductor that takes the metal and passes it on. So we'll be able to see. I don't think we got any of these over there, but so liquid tight. If we break the ground with a liquid tight connector, then we're going to have to reestablish the ground, right? Everybody understand that? Wireways and wire ducts. We have, that's not with a K. We have cable trays, we have ladder, trough, channel, and solid bottom. And the next slide should give you all a real nice picture of the difference between these cable trays that we run. All these make sense? Huh? Are we all okay? I know it's hard to see on the slides, but you know, I think these show up pretty good on the small slides, I think. Aerial installation, high capacity, low maintenance types of installation. We have what we call triplex, which should be 3 conductors in a jacket. We have quadruplex, which would be 4 conductors, non-insulated, solid or pipe. Of course, anything that's installed outside needs to be able to withstand high winds and storms and ice situations, right? As much as they can. We hadn't had a big old ice storm here in a long time. But when ice comes in, it adds a lot of weight. And what happens? We have tree limbs that fall, and we have the power cables that break. Everybody's seen these power poles all over the place. This is called a cross type, cross arm. And we have these all over the place. A lot of people call them telephone poles. But are we okay? Down drops for houses. Y'all seen those, right? Normally we have a transformer up here. It's not underground cable. It's underground cable, and we don't have a lot of underground for residential in the state of Alabama. We do have some. Some of these real expensive neighborhoods, or the way they're building them now, they're doing a lot of underground cable work. Now, what advantage? Why does Alabama Power like above ground? It's easier to fix. Yeah, if it breaks underground, then that's going to be a mess, right? You understand that? A lot of the cable that they run is not run through conduit. It has a jacket on it that protects it from ground. So a lot of your underground cables are just dug in and they drop it right in the ground, cover it back up. Which means if something happens and one of those cables break, or we get a short or something under there, they're literally going to have to come in and dig up the neighborhood. And they don't usually run in straight lines either. So you know, they have to dodge water mains and all this other kind of stuff. So I don't know if y'all seen these guys finding these pipes or finding these conductors. You'll see them on the side of the road. They'll be waving that wand under there, and they have that little spray can that they spray to mark it so they can actually find the path of some of these lines. So normally what we'll have is we'll have a transformer up here, mounted here. and then it'll usually come up to some type of insulator. Ceramic used to be glass, but glass became pretty expensive. And that's one of the things that people like to collect is glass insulators. I don't know if you've seen them. It'll come up here to something ceramic. Ceramic we just made. And then they'll drop a triplex, which means what? Triplex cable down to your house. So if you went down to Lowe's and you wanted a down drop, this is what you would buy. You'd buy a triplex cable. It means what? Tri means what? 3. So there's 3 conductors. Normally we have 2 that are insulated, and then they're wrapped around. They're literally wrapped around a ground. So that ground is your ground. This drops down to your house. Normally on your house, they'll run it down to your meter. And then you'll have another ground plug right here. Up here, the ground is established with a copper wire that comes down and runs into the ground by the pole where your transformer is at. So that's what they mean by triplex. So we have 2 insulated, and then 1 that's not insulated, because this ground is at ground potential, right? You understand that? So all power is Alabama Power, that voltage is looking for ground. Well, if that sucker's at ground potential, then we don't have to insulate that. So this is a typical residential down drop in the state of Alabama. Unless it's underground. Underground looks really, really pretty, but hopefully you kind of pray that nothing extra actually has to happen, or they will come in and dig up your neighborhood, right? Underground's also got the advantage of that we don't have to worry about ice, and we don't have to worry about high wind. You have to worry about tornadoes, because it can tear up all those transformers. So you still have to have the transformers. Normally the transformers are above ground, but they look very similar to the boxes that the phone company puts up, the big gray boxes. Underground cable, buried underground cable. That's basically what it is. They got those real neat machines now. I don't know if you've seen it when they run the fiber optic cable, where they literally burr and pull the cables as they're going along, which is pretty neat. Cable pulling. Cables have to be pulled through conduit, floor races, raceways. So the act of pulling is when we put those cables or those conductors into those raceways. Either a conduit, usually when we use conduit, when we use the term conduit, usually we're talking about the round tubing. And then the other guys, we call them troughs or raceways. Cables have to be pulled through conduit, floor raceways, enable trays, wires, molds, and metal raceways. Before pulling, you need to check your National Electrical Code about charts to determine the suitability of the cable for the chosen job. So we're making sure we put the right current in there. You pull all this wire, then you get in there and realize you pulled the wrong gauge wire. That's going to be awful, right? Or you don't use the right jacket on the wire. You run it through an environment that wire is not rated to. Check the temperature and the weight of the cable, because we're going to start pulling. And when we pull something, we create across something, we create friction, right? You understand? And of course, what determines the amount of friction is the 2 surfaces that you're being pulled, right, that are in contact with each other, and then the weight of what you're pulling. And the problem is, if you pull these cables too hard, it's either going to break them or it's going to stretch them. And if you stretch them, you change the gauge of the cable, of the wire. If you change the gauge of the wire, you change the ampacity of the wire, right? You understand that? So there's a lot to pulling cables. Check the temperature rating of the weight in the cable, survey the environment and terrain, measure the length of the cable run to determine the amount of cable required. We don't like splices inside conduit. So what you do is that you make sure that you have enough cable to make the entire run to the box that you want to go to. If you run in, and we don't like it, but my son moved into First house he bought was actually a trailer, and he put it down in a trailer park at Opp, and all their cables were underground. So we had to figure out. So we had to run. Somebody had to run the power from the box over to his trailer. His wife's dad went out there and stepped off the cable and called me and told me how much I needed to buy. But he didn't measure it into the trailer. He just measured it to where it went up. So when I bought the cable and got down to Opp and we started pulling it, what happened? I ran out of cable. So we went to the building supply and we spliced it inside there, but we wasn't supposed to. Luckily, he's not in that trailer anymore. Once you pull it like that, then Lowe's won't take it back. So what you need to do is, but that Opp's a long way, so I should have went down there and measured myself before I went and bought it, but cable pulling, inserting on the pull line, we can use existing rope. So when I put my sheds out the back of my house, I ran PVC conduit under the ground, and I went ahead and used one, and now I've got a rope in the other. So that way, if I decide what I want to put out there, I've already got a pull rope in there. So existing rope, fish tape, or vacuum pressure. The rigging is the type of tape connections, wire mesh grips, simplex and duplex grips, and then compression eye pulley eyes. We'll look at some of these. They have pretty good pictures of these. We got a wire mesh grip around here somewhere. That's what I tried to look for. See if we can find it. So this is vacuum pulling. When I was looking this up on the internet to find one, I wish I could find that. The guy actually made a vacuum puller using a standard shop vac and a baggie, which is really, really neat. We'll see if we can find that again. But so this is pulling cable through through conduit using a vacuum. And this is done a lot on long runs. So let me hook my speaker back up. See if it's plugged in. Sounds like it. Of course, this is the. So these guys are trying to get these cables through a long conduit that runs under the street. Oops, sorry. Did you hear that? Huh? Oh, I see. Yeah. Turned it up. All right. This looks like it's. This is basically just an air pump. See, they're going to put a special seal on there that size of conduit trying to flow through it. Come on, skip over. So they can actually show it doing. This is cable lube that they're putting. We'll talk about it in a minute. So you can buy the cable lube. Some people use regular Info. So he said a missile attached to a swivel attached to a pull eye. Optical cable, so that's fiber cable to pull through. You see the cable go. So what do they literally do? So they have he called it a missile. They have a plug in front of there that creates a big seal. They just do what? Connect the cable to that and push that plug through there. It follows the conduit. I don't know how far they're trying to take it to, but this is where it's supposed to come up at. I don't know how far away it is. Looks like it's on the other side of the. So that was a vacuum slash blower, right? And there's a video up there where a guy takes a rope. He doesn't pull the cable. He pushes a rope, but he just takes a sandwich bag and wraps it around the end of his rope he's trying to pull, or he tapes it all together. He puts it in the conduit and uses a shop vac on the other end to suck that bag through there with the rope on it. And then he connects the rope to the cable. I'll put that video up. I'll have to clip it out of the slides because when I put it on the PowerPoints on here, the audio is not recorded. The other way we pull it most often is we pull it with what we call fish tape. And I don't have any pictures of that. So these are images of fish tape, and we have several of these. So what you got, a flexible steel conductor in it as soon as it comes up, which it's not. And can you see the hook in here? And so what we do is we connect, we feed this thing through, and we can see a guy here fishing it through. You know, see that? And he takes this and fishes it through the conduit in the direction we gotta go. We go. So when they do the conduit, we have special joints and stuff that we put that does 90s and stuff like that. And these are sized so that the conduit, so the fish tape will slide through that. Once we get to the other side, then somehow we connect the cable to the fish tape. We either connect a pull rope and pull the rope back through. So if I'm going to pull a really big cable, normally what we do is we'll use a fish tape to pull the rope back through, and then we pull it with the rope. The smaller cables or conductors, we'll connect them directly to that hook on the fish tape, and we'll cover it up real good with electrical tape, and then we'll pull it directly with fish tape. So it all depends on how many conductors or how big of the cable is you're trying to pull through. Sometimes we lubricate the cable while it's being pulled. Sometimes we don't. It all depends on how far we're going to pull it. Sometimes the conduit is a straight run, and we're running solid strand wire. Sometimes we can just push the wire through the conduit. But we'll go over there and let y'all see some fish tapes and actually see about this. So these are fish tapes. And the purpose of fish tape is to pull the conductor through the box. So we call these device boxes right here, and device boxes are used. We have junction boxes that we put every once in a while. Sometimes we put multiple junction boxes because of the length of the pull. So what we'll do is we're trying to pull a heavy cable through there, and the longer you pull the cable, the more friction you get, right? Which makes the cable harder to pull. So what they'll do is they'll put pull boxes in there. And what we'll do is instead of pulling the entire length, what will they do? Well, they'll pull it to a pull box, and then they'll pull from the pull box down to the other. Device boxes where actually you mount electrical devices in, like switches and light lamps and stuff like that. So we have different types. We have wire pulling, where we actually connect it to the fish tape. And what we do is we pencil this tape down, and then we take it and we cover everything out. We want this to be kind of in the shape of a pencil, right? You understand? We want it narrow on the front and then move it back. And it takes a lot of tape to get that done. We don't want many humps as we can possibly get. And then what we do is we actually use the conductors. We'll strip the conductors, we'll hook the conductors around, we'll twist them together, we'll tape them down real good and use that to actually pull with. We have these pulling grips, which I'll try to find that. So a pulling grip acts a lot like the Chinese finger traps you used to play with when you was a kid, where you push your fingers in there, and then when you try to pull them out, you couldn't pull them out because they would collapse on there. These are also called Cleanum grips, by the way, but these guys here are used a lot. Then we usually have what we call a swivel, because the cable is coming off of a rope. And a lot of y'all, if you've ever been fishing and you use a bait that wants to spin around, you put a swivel out there, because if you don't, what's going to happen? It's going to coil your line up when it comes back. And also, when you fish and it's wound up and you throw your fishing reel out there, then it's going to have that spool in it, and it's going to try to make whatever lure you're pulling trying to roll, right? You understand that? So if you're fishing, you've definitely seen what we call swivels. But those swivels are used in there to allow the bait to spin without spinning the line, and this would be the same thing. What happens is that when you're pulling that cable and it's coming off a roll, it's going to have these loops in there anyway, which is going to try to make it turn, right? You understand? So other pulling grips. So we have a pulling grips that has where we can actually encapsulate the cable and the junction and everything inside these things. They'll have protection for the cable, and then they'll have something over here that we can hook it up to a pulling rope, or we can hook it up to a fish tape. Then we have certain pulling grips where we can put multiple cables into and pull multiple cables at the same time. We have pulling eyes. So pulling eyes is like a crimp connector, where we come in and we actually crimp this onto the conductor and the jacket. So that way we get a lot of strength with these things, because not only are we pulling the conductor, but we're also pulling it with the jacket. A lot of cables will have a pull member in it. They'll have a piece of nylon cord or something inside the cable that we're supposed to make sure we get that into the fish tape. So that way we're pulling with not only with the wires, but we're also pulling with the pulling member. Swivels, everybody okay on those? Do y'all know what a swivel is? You okay with a swivel? I have a pulling grip around here somewhere that I'll try to find. I've got one with a swivel on it that I bought down at Lowe's, but I hadn't seen it in a while. We hadn't taught the class in a while. We have sheaves, which are pulling assemblies. We have protectors, and we have pulling machines. You get into some of these big, heavy gauge wires, or these cables that's got a lot of conductors in it, then you're not going to be able to pull those with your hand. So we have manually operated pulling devices, which you have a crank on them. They act a lot like the, what do you call them? God, I've got two of them at the house. We have the steel, come along. They call them come along. Yeah, come along is you got a handle on it that gives you leverage, and then you got a long wire rope you put on it, and you can use it to like pull cars. And I've got two of them at the house. You can do a lot of it. And then we have motorized pulling machine. First time I ever run into was out at US Steel when they was pulling some heavy gauge cable, and it was pretty neat. These are swivels. So notice we have a nut on this side, a nut on this side. Usually it's locked down, and it has the ability to spin, so both sides can spin. These are pulling sheaves. What a sheave does is it changes the direction of the pulling force. So this is down inside a manhole. So this is this would be the conduit down here coming out, right? And then we're up here. Well, we don't want to pull it up here and let the cable move across a surface like that. So we have what we call a pulling sheave. So what's the purpose of a pulling sheave? It's just made up of a couple of pulleys. They have troughs in them so the cable can fit into the pulleys. And then now we can do what? Now we can pull, and we can change the direction of the pull without harming the cable. Are we okay? So you know what a sheave is, right? This is a hand-operated puller. So what you do is you force this into the at the conduit. You put this against your waist, and you just crank that thing, and you get that mechanical advantage of you know, the lever action. These are motorized pullers. They have a capstan on it. Normally we don't. Normally we use this with a pulling rope. So we'll actually connect the rope to the cable, and then we use the puller to pull the rope. This is a real good picture right here. So what we do on the capstan is it's laced over there, and if you pull tight on it and then you pull, if you let it off, then it'll stop pulling. And this is a really good picture right here. So this guy here is holding tension on the cable all the time. This is the pulling rope. This unit is it's got the pulling sheave on it. Can y'all see the pulling sheave? Because what the pulling sheave does is it changes the direction of the pull. So the cable, the rope that's got the cable attached to it actually comes down through here, goes through the sheave, comes down to the capstan. And what it is that it's using a nylon rope, and as long as he holds tension on it and keeps pulling on this side, then it'll pull. But as soon as something goes wrong, he can just do what? He can let go of the tension of the rope, and then it starts sliding on the capstan, and it won't pull anymore. So this is a power puller. They had one of these on the Birmingham. They had a bunch of stuff over there, but somehow it got gone. Greenlee is a company that is very big in electrical equipment, terminations and that kind of stuff, and pullers and benders and all kinds of things. Preparing the cable for pulling. Check the prints to determine the proper routing. Ensure that the splice and termination points are correct. Check that all necessary materials are available. Check that the pull will occur at a temperature that is suitable. We don't like to pull at extremely cold temperatures, and why is that? Yeah, well, and also the cable don't flex as easy. Extremely hot temperatures means you get more friction, right, on your jackets. Verify the proper color codes are being used. That's awful. You know, you go out and you start pulling cable, and then you realize you pulled the wrong cable. I mean, that's awful. Determine the correct pulling direction. Calculate the cable sidewall pressure for each pull. And that's what we're talking about, the friction. Position the cable and rails and sheaves properly, and watch for sharp bends and kinks in the cable, because that can really damage the cable, right? Determine the proper number of personnel required for feeding the cable into the conduit. Be sure that an ample supply of pulling lubricant. And I can't see what that's what it says at the bottom. So pulling lubricant is just something that we smear on the cable while it's being pulled to reduce friction, right? Are you okay? Two-way voice and hand signal communication must be established prior to the pull. So if you're pulling over great lengths and you've got multiple personnel together, if you're going to use hand signals, you need to do what? You need to make sure everybody understands the hand signals. So you see the guy when they was pulling that cable, he got everybody together and went over everything that was going to happen. You see these people at big construction sites, they're going to do a lift. They get everybody together and explain exactly what's going on, so they don't want to get people hurt. Short runs may be pulled by hand. The cable should be fed as straight as possible into the conduit. If basket scripts are used, sufficient tension must be maintained to get a positive grip. Apply pulling lubricant to the cable constantly during the pull. Make sure sheaves are the proper size and the right directions, right? Leave some slack if the cable is to be pulled through a box. Be certain that to tag and identify the cables at the pull box, junction box, and terminal points. Correct pulling tension must be calculated before pulling starts. So you'll give y'all a little formula that you use to calculate pulling tensions on cables, depending on the number of conductors. All this makes sense? Pretty most of this is just common sense. You start pulling a cable and then it breaks halfway in between, or if you have to pull it too hard and you change the tension, or you pull the wrong cable, and you got to figure out how to get that thing out of there, it's a big problem. We were putting a scale in down in Montgomery, and they didn't run the right side conduit to pull the cables that we needed to pull, and that was a mess. During the pull, avoid cable crossovers where cables are entering the conduit. Observe special care when pulling cables through manholes where damage may occur. Use guide sheave racks where required. Do not allow vertical conduit rise to support conduit fittings. I understand that. What does that mean? What does a rise mean? So this is a rise back here. So when you put a fitting on the conduit, you don't want that fitting to support the rise, to support the conduit. So what do? Well, you use clamps, you use braces, and all kinds of stuff. This is especially true on EMT. On EMT, you never want a joint or to support the conduit. Everybody understand that? You want to bolt that stuff to the wall, right? Do not hammer cables into fittings. Do not, such hammerings can damage the cables. Consider sidewall pressure for vertical hanging cables. Bend around corners. We have people that'll take cables up a long distance and then others lay them over a corner of something. And what's the problem? Well, that corner is supporting all the cable weight, right? You understand that? People don't understand. It's like roofs. You know, if you've got shingle roofing on your house, you know, you pick up one of those shingles, they don't weigh hardly anything, right? You understand? You wonder why ceilings collapse when they get snow on them. You know, you can pick up a handful of snow and it don't weigh anything, but then you start talking about inches of snow and all that does what? It all adds together. So ceilings, I've seen ceilings actually warp and break in because people put too many layers of roofing up there. So we need to consider that sidewall pressure when we come up here and we start hanging cables. The direction of pulls and the number of pins affects tension of the cable. Bends are when we change the direction of the conduit. So normally conduit is straight, right? You understand that? So if we look at this conduit right here, what do we see? It moves up the wall. We can see the bracing all the way up, right? You understand that? And then we get to that overlap over there, we see what we call a bend. Well, when I pull that around the bend, that's going to add more pressure to the sides of the cables that I'm trying to pull, right? You understand? And then it goes up and then it makes a 90-degree turn up there. And then it comes over here and makes another 90-degree turn. Well, every one of those bends are going to cause what? Are going to cause sidewall pressure when we try to pull that through. So very few conduit is straight. We're going to have to bend it around stuff. We're going to have to put couplers in there and all kinds of stuff that we're going to have to take into consideration when we start pulling that stuff. Be certain that the conduit or cable tray is clear of debris and foreign particles. So what they did on that video is they actually blew high pressure air through the conduit before they did what? Before they pulled the cable. On long pulls, pull boxes, pull from a pull box to the center. This reduces the pull tissue by half. And we talked about what we call a pull box, right? You understand that? So a lot of times on long runs, and we even see this, they're pulling fiber out on the road beside my house. And every once in a while they got a box there. Well, that's not a, you understand, that's not a box in there. Nobody lives there, but it's what we call a pull box. So they didn't do what? So they actually broke the pull up in length so they wouldn't put too much pressure on pulling that cable. They use protectors inserted into the entry of the conduit. So what we have on metal conduit is we have these little sleeves that we can put in there that's got this Teflon on the side with a cable, and we're pulling it through. Actually pulls across that. Most of the connectors that you have that are inside toolboxes will have those sleeves inside those connectors. We're pulling cable into enclosures with energized conductors. We use barriers and guards to be certain that inadvertent contact is made with those live conductors. So I got boxes, and I'm pulling a cable, and they can't shut the plant down for me to pull that new cable. So it means when I open that cabinet up, there might be some high voltage in there, right? You understand? And I'm trying to pull the cable. But what we need to do is we need to put up barriers and guards and everything around those live circuits so those guys won't accidentally get in there while they're pulling those cables. Okay, guys, y'all take another 10-minute break. I'll pass this around to y'all. This is the pulling or the cleaning grip, pulling grip that they were talking about. So notice it's got a wire mesh on it. And what you do is insert your cable, and push it in, and of course that makes it spread out, right? And then you insert your cable. And then you buy these for different gauge wires, and then when you pull it in, and then you try to pull it out. So don't just stick those fingers in it, because it'll grab onto it. It works just like what we used to have Chinese finger traps. Y'all seen those before? Which is pretty neat. People get in there, they don't understand. You got to push it in like this to make them expand out. Excuse me. See, this doesn't have. This is not the one that I was looking for. The one that I had belongs to me. I had swivel on. So these guys right here. The wire mesh grips. It's also called Cleanum grips, by the way. And I can't remember exactly how it's spelled. It starts with a K, K-L-E-U-M, I think so. So this is basically this one, and you buy them for different gauge wires that you're going to use it to hook onto the wires and pull. What's nice about those things is they grab onto the jacket, and so you're not actually pulling with the conductor, you're actually pulling with the jacket, which is also what these soldering irons are trying to do. So if we got one of the two, of course, we would like to pull with the jacket, and then instead of trying to pull with the conductors. So these are installing cables into cable troughs or cable trays. And this would actually be the roller. This is probably a different picture. So what we're doing is we have a set of cable pulleys here. And what they're trying to do is prevent this cable from pulling against or up against that friction right there. So this is one thing you got to consider when you pull these things through to these cable troughs or these cable trays. Pulling lubricant, so motor oil, grease. The problem with using motor oil and grease is that this is going to stay on the cable forever, right? You understand? It's going to goop up stuff. So we have different types that will actually degrade over time. Glycerin water emulsion, this guy right here, what's that, bentonite, clay water, polymer water, and hydrocarbon water. But if we come up here and look at, go on the internet and look up cable pulling lubricants. Hopefully something doesn't pop up. It's not supposed to. And we should have several images of this stuff. So it comes in bulk, comes in these tubes. I don't know if you can find the bulk down at Lowe's or not, but they have the cable pulling lubrication. And of course what this is for is to slick up the outside jacket of the conductors or the cables so we reduced the pulling friction, right? There was some neat videos on YouTube pulling some huge cables into a powerhouse. And they had a guy sitting out there, it was in a ditch, and that's what he did. He was just keeping goop on those, keeping that pulling lubricant on those cables while it was being pulled through those, through the conduit. And we could probably see, yeah, all kind of guys just putting all that pulling lubricant on there while they're, while the cables, there's a spray lubricant, but, I don't know. So this guy's got, but that he's doing. Hands are just. And I don't know exactly what they sell down at Lowe's. I just know they sell it. So what's the purpose of the pulling lubricant? Yeah, it just coats the outside jacket with a lubricant, right? I've seen people use hand soap to do that to help it. I haven't ever seen people use motor oil or grease, but I guess that could be okay. Normally we want to use some type of lubricant that'll degrade and won't hurt the cable or the jacket over time. This is pulling tension, should not exceed 0.008 times the circular mil area, which is KCM, by the way. So this is what you're supposed to do. This is rule of thumb if it's not listed. Is you take 0.008, what's N? And then the what? KCM of the cable, right? And then multiply that out, and your answer is going to be in what? Would be the amount of torque, tension, I'm sorry, that you could put on this. And you'll see a lot of places they'll actually put a gauge in there. I've seen people use fish gauges and actually put the fish gauge between the puller and the cable. And while they're pulling that stuff out, they monitor it to make sure they don't exceed the full tension of the cable. This is a rule of thumb formula where we can calculate the amount of tension, right? Tension in pounds. We multiply it by 0.008, then times the watt, times the number of conductors in the cable, times the KC mils of the conductor, and then that should give us. Now here's where, if you didn't have the gauge, if you were given the gauge, then you're going to have to look that up and calculate the KC mil, right? How do you calculate KC mils? You just square and multiply watt by what? 1,000. And guys, I think we're going to expose cable insulation, protection against penetration of screws and nails. We run into this a lot, especially in house wiring, where we use all these cable nails that we put down, these U-shaped nails. People will drive those things in and get them in there too tight. People don't protect the cable. A lot of times in residential wiring, we run the wire through the 2x4s in the wall. And people will come in there nailing up sheetrock and all kind of stuff, and they'll nail into the wire, right? You understand that? They don't nail straight, and they'll come out the side and get into our wiring that's inside the house. They do make little metal plates, by the way, in residential wiring that you can put right where you put that 1/4 inch hole through. I mean, 3/4 inch hole through the stud, where you can cover that thing up, and if somebody does drive a nail through there, it's going to be hard. So usually, especially when they're doing sheetrocking, when sheetrock nails you should not have any problems with if the cables are running there right, because what they're supposed to do is drill those holes in the center of the 2x4. In fact, you can go down to Lowe's. We do so much wiring through walls in residential. You can buy the 2x4s with the holes already cut through there to run those cables through there. If not, then you gotta drill them in there yourself. So people drive nails into there. They don't. When the cables have passed through wood members, holes must be drilled or notched. Notches made. When cables pass through metal framing members or behind panels, they should be protected with bushings and grommets securely fastened to the opening. So we'll go over there and look at the commercial wiring lab. We have two types of, we have metal studs over there, and we have wood studs. Metal studs are very popular in commercial buildings, also industrial applications. For one reason, they're easier to take apart and put down. I saw them build a house out in Tanny Hill, and that's what they use. They use all metal studs in there instead of using 2x4s, which is pretty interesting. These are like I said, we'll have to look back. Cable troughs, cable routes underground or beneath buildings must be in a raceway that extends beyond the walls of the building. Any cable or conductor that emerges from the ground must be protected by closed or raceways. We don't want, especially if you're running conduit, we don't want liquids to get down inside the conduit, right? Conductors or cables that enter a building must be protected at the point of entrance. Cables must also be protected if they are in the immediate area of any activity where people are walking or over. So most of this stuff is pretty much, well, just common sense, right? So conduits are in there to protect the conductor, but we also got to protect the conduit too. So some places you have to use rigid conduit. Some places you can use EMT conduit. We like EMT. This is all EMT that they got running on the wall over there, because when we get to these joints or these places that we need to change altitude or move it away, we can bend it, right? You understand? If you take the commercial wiring course, part of that class is learning how to bend that conduit. You see these electricians did a really well job of bending those conduits and making their measurements to make it come out exactly the way it's supposed to be. And of course, we'll look at this, the bending radius. You have to maintain a radius of the bend. We don't want it to be too sharp. Why don't we want it to be too sharp? Yeah, and increase the pull tension when you're coming around it. And we don't want it to be too long or it eat up a lot of space on our wall. So we don't want it to go like that, right? You understand? So there's definitions. So the bend radius, and what's nice about most of your conduit benders is they are actually designed to give you the right bend radius. So we have some foot benders over in the lab. So we'll try to get over there next class. Probably not the whole class, but just go over there and look. In fact, we might do that today. Just go over there and look at some conduit. Just go over there and look at the benders, foot benders. I think he might have a power bender over there, which is more inclined to the real big conduit or rigid conduit. So if you go to your house or out on a telephone pole, you see they usually have rigid conduit out there. Anything that's going to be self-supporting is usually rigid, or something that's going to move around a lot. A lot of times we use flex conduit. So And then I don't know if we got any raceway over there. This is actually the end of the conduit. And what we'll do here is we'll start talking about some of our communication cables. So what we'll have to do next class is we'll have to talk a little bit about impedance and characteristics impedance of communication cables and stuff like that we have to make sure that we maintain. So y'all know where the commercial wiring lab's at? Or do y'all know where the motor control lab's at? It's the room right next to it, right at the turn where it corners up and goes back toward 200. So 206 is usually the lab y'all might have used when you was in EP100. Motor controls lab and A2. So this is A206 is where we're going to go to look around at some of the stuff over there. So let's go ahead and meet over there. Oh, by the way, official course road. Wesley, you're on here. James, you're on here. What that means is you haven't paid your tuition yet. I think tuition is due by, let me look at the email real quick so we can do this. Y'all have. Y'all on the official course. So let me bring up my email real quick before we go over there, and bring up Dr. Crawford's email about when you need to get your tuition paid. I think it's, they should have sent the email out to you. I don't see it, guys. Let me give y'all the actual date here. Monday the 19th, the next Monday, right? By 5 p.m. And I don't know why it showed up here. This is the same mail. Let's go ahead and meet over there. Let me go ahead and of course, what we do over there is not going to be recorded, unfortunately. So. And